Hi, this is another A session, Assistance with Chemistry Exercises, and the problem for this video is fill in each box with the correct Gilman reagent to complete the reactions, then show how to make each Gilman reagent starting from an alkyl halide. These Gilman reagents are also known as Dialkylcopper reagents or Lithium diorganocopper reagents, and they're typically used to make larger hydrocarbons. Okay, let us remind ourselves what a Gilman reagent can do. A Gilman reagent looks like this. Let me draw a simple one, maybe an ethyl Gilman. Simple, but at first hard to conceptualize. We have two alkyl groups on this copper-lithium complex, and it's the same as us drawing this. Copper, in this case, will be negative, and the counter-ion lithium will be right there. You could take a Gilman reagent. I'll just call these from now on Gilman reagents. And you can react them with any alkyl halide. So for instance, if I have this ethyl Gilman, and I react it with this alkyl halide, okay, I'm going to make a connection between this carbon that's connected to the copper and this carbon connected to the bromine. Because we do have opposites attract, this is partial negative, and because this bromine is partial negative, that renders this carbon to be partial positive. The trick with these types of reactions is, as in many cases, make sure you make the right connection and represent it correctly on your paper. I'll draw the alkyl halide part first. When you connect this carbon with this dot, the leaving group leaves. So, what should I do? Here's the dot, and I connected it to this carbon, which is connected to this methyl. You could double check by counting the carbons. Within the parentheses, you have two carbons, a C2 piece. This alkyl halide has 1, 2, 3, 4, 5, 6. Hopefully there's 8 carbons here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Yes, you only add the alkyl group once. Maybe that's what sometimes is confusing to students. The connection that was made, when you have this hydrocarbon and without any other information, you wouldn't know really which carbon-carbon bond was made. But because we had started with this Gilman reagent, we know that we made this carbon-carbon bond, the 2-piece plus the 6-piece, 6-carbon piece. So let's analyze our first reaction. And here's our alkyl halide. There's a Gilman reagent that should be here. Well, definitely we made this bond. Okay, and I'm going to put a dot here. That's where this dot is part of the Gilman reagent. And actually these 4 carbons should be within the parentheses. Okay, so let me redraw this problem down here. And again, we're making this carbon-carbon bond. Well, that was this. How should I draw this? 1, 2, 3, 4 carbons. So you gotta draw that line extending outside of the parentheses, and that's connected to the copper lithium complex. So whatever's in the parentheses is what you're adding to your alkyl halide. So I know I put a dot here to indicate the connection to the alkyl group of the Gilman. Typically I like to put a dot on the alkyl halide carbon that was attacked. So technically I should have put a dot here, but it's the connection between these two dots basically. And we have this. Okay. 4 carbons within the parentheses. Now, what would be incorrect is if I had drawn this. So I have this, and then if my parentheses drawing is a little bit sloppy, right? I don't know what I mean by putting the parentheses through this carbon. Is the carbon within the parentheses or outside of the parentheses? So this would be a very bad representation of the Gilman reagent. Make sure you bisect the bond. Now how do we make this? Well, you make it from the alkyl halide equivalent. And that was the other part of the problem. Then show how to make each Gilman reagent starting from an alkyl halide. I'll start with a bromine, and you just take the same 4 carbons and put a bromine. Okay. How you make the Gilman is you make the organolithium, actually. And then you add copper iodide. It's actually 2 organolithium molecules and 1 copper iodide to give us our 2 alkyl groups. And how am I going to draw this? I'll just stay consistent and draw the one with parentheses. So if you're wondering what's going on with this iodide, well, it paired up with the lithium because there are 2 of these, right? But when we added the 2 alkyl groups, but we only used 1 lithium. And just as a reminder, right? See, that's how it looks like all drawn out without the parentheses. Okay, shall we try this one here? Okay, let me draw my dot on the carbon that is going to be attacked, because it's really, right, the copper copper reagent, the Gilman reagent, that is doing the attacking the alkyl halide. I'm not going to show you the mechanism, but you can imagine this attraction from the partial negative to the partial positive. Okay, so there's the alkyl halide that I'm going to attack with a Gilman reagent, meaning that the bond that was made was this one. So my Gilman reagent needs to look like this, but the tricky part is how do you draw it? Okay, I know it has 4 carbons, but can we get it into the right format? So within my parentheses, I want to extend this bond outside of parentheses to the copper lithium. So I am going to turn this over and have the Y shape on the left side. I'm going to extend out beyond the parentheses to my copper lithium. You can see this is going to take a little bit of practice, but then you can double check. You could even number the carbons if you want, because remember, it's the carbon that's connected to the metal that's doing the attacking on this dot right here. Because this is the carbon that is a partial negative, right? And this is the partial positive carbon right here. So do you see how that when we make a bond between this carbon and this dot, it's between this carbon and this dot. Same set of carbons. That's the correct Gilman reagent. Now, how do we make that? Just like we made the Gilman reagent here. I'll take an alkyl halide with the same carbon skeleton, convert it to the organolithium, add copper iodide. In organic chemistry, in the lab, of course you're worried about amounts and stoichiometry, but when you write it out as a reaction, typically you just, you don't worry about it. So I'm not going to put a 2 here, even though it is a 2-to-1 ratio. And again, make sure you extend outside the parentheses, the bond going to the copper. These carbons have to stay fully within the parentheses. And then we have copper, lithium. And that's the Gilman reagent. Okay? It can be a little bit confusing, especially if you start from the alkyl halide to make the copper lithium, because you're using an alkyl halide twice. This alkyl halide is used to make the Gilman reagent, and then the Gilman reagent attacks another alkyl halide to make your hydrocarbon.